So today I'm basically gonna be talking about my CA. So basically what did I do for this CA? I'm gonna show you all the equations that I use. I'm gonna explain all the graphs that I drew for the CA, or like, well, not all of them, but like, most of them. So first I'm gonna explain the task 1 part 1 of the question because it asked me to produce a straight line motion. So if I go over here, yeah, if I go up, yeah, so basically first thing I did for a straight line motion is that I got my points, and I used those points and a formula y2 minus y1 over x2 minus x1 to get my slope of the line. So that's the formula here. And using the slope of the line and one of the points, so either x1 y1 or x2 y2, I used those to basically get the equation of a line, and that would help me later to kind of draw the line. Now in the final form here, I actually wrote it in the form of x, comma, 3x minus 16. So basically, in order to get the y, I substituted x for t. So we have 3x minus 16 here, and I substituted in for that, basically, for t. Now I have plus 1 over here because we initially started at position 1, so x1 is equal to 1. So if it would be equal to 2, basically it will be plus 2 instead of plus 1. Now over here in the brackets, it's actually 10 divided by 6, because if we look at here, we start at 1 and we want to get at 11. So basically we want to go up by 10 units in 6 seconds, because in question it specifies that you want to do it to cover that distance in 6 seconds. So basically it's 10 over 6, and that basically my formula to get the y movement, and in order to get the x movement you just substitute in for the x, and you do the same, and you get your straight line motion. Now the thing for the straight line motion is that you have to keep y and x both to the power of 1, because if you actually have y or x squared or cubed or anything like that, it's not going to produce a straight line anymore. It's not a straight line. So basically you have to keep y and x to the power of 1. Now, so that pretty much explains for the straight line motion. Now if I go here and explain next, yes, the wave type motion. So for task 2 part 3 I got the wave type kind of motion. Now in order to produce a wave type of motion, you have to have basically, well in this case it's a vertical oscillation. So basically you have to have x oscillating between 2 points. So in this case for me it's 1 and minus 1. And basically the y value is basically the value that changes over time. So as the time increases, the y value, kind of decreases or gets bigger smaller actually in this case. But actually, if I would actually increase the time, basically the wave would actually go down even further. Now, if I want to have it in the going in the horizontal direction, I would have y be cos bracket t bracket, in order to basically have it oscillating between 2 points. So either would be, I don't know, 50 and minus 50, or 100 and minus 100 and 100, and x would be the value that would change over time. So as the time would increase, basically the x would increase, and so on. So that basically covers it for the wave type motion, and the next type kind of motion I'm going to explain is the circular type of motion. Now the thing about creating a circular type of motion is that you have to keep both radius and speed or time at the same kind of values for both. Now in this case the center is in 0, 0, so basically there are no values in front of the sin or cos, and the time is basically the same. But if I would say, for example, here, if I would change that, actually let me demonstrate it to you. If I change that here to, let's see, so if I change that to, let's say, plus 1, and here, yeah, so plus 1, and I would just drag that down, and I would actually do the same. Oh, actually, yeah, that kind of works too. You see the center now is like in x1 and y0, so basically it's shifted over. So that basically, the value in the value at the back here basically controls the center point. So let me just change that back to 0 here, and oh, actually no, I had to do it here. Sorry, just give me a minute. And wrong. Yes, that, and bam. Okay. So now basically I'm going to talk kind of about the circle and how to create the motion of it, just like in general. So if I go over here to my workings, wherever I have them, yeah, here. So basically, these are two formulas that you have to use to create a circle. Now it can be either like a, it has to be either this one, which is the sin first and then the cos later, or the cos first and the sin later, but that really depends on the kind of a circle you're drawing. Now, so basically the a value here basically controls the radius of the circle. Now both of these values, regardless of which equation you use, have to be equal, because if I go and show you over here, so the radius have to be equal for both equations, otherwise it's not going to produce a circle, successfully. So in this example, actually over here, you can see basically the radiuses are both different, and here it's like, 5, and here it's like 2, and produces just this kind of, well, I don't know, deformed circle, I guess you can call it. So basically it doesn't produce a successful circle. So that basically has to, basically you have to keep the radius or the a value in both the same. Now basically the BT is kind of the change over time, or basically your degrees. So both of the change over time has to be the same again for both of the equations, for both cos and sin, because otherwise it's not going to produce a circle. It's going to produce instead kind of two kind of waves overlapping each other. So in here we have 3t and 2t, the x value and the y value are going at different speeds, and that basically causes them to kind of, produces waves that just overlap each other. So that basically pretty much covers it for like the, speed of the circle. What else do I have to talk about? The center. Now the center of the circle is actually controlled by C0 and C1. Actually, no, wait, here, C1, yeah. So basically, as I showed earlier in one of the circles. Now, but since the circle I showed had the center 0, 0, there were no values here. But since I added like a value of 1 over here, it basically shifted over, and the center was at 0, 1 instead of 0, 0. So basically, through the C0 and C1, you control the center of the circle. And if you change any of those values, you're going to basically have, your circle. You can just move. You can use those to basically move your circle around the graph. And the starting point of your motion is really kind of decided by your question, I think. But but if you actually look at it here in the previous example I was using, yeah. Yeah, so basically the motion of the starting point of your circle is basically given to you. So like if you want it at 0, you basically have it's given to you already that it's in 0, 1. So that basically pretty much covers the starting point. So that's basically pretty much for my CA and the graphs that I drew, and I hope that everything is clear that I have done. So that's it. Yeah.